Welcome back to NTRAS, video 4 of our home lab setup. In the previous videos, we discussed and configured a Cisco 3560CX Layer 3 switch that provided IP routing between our different systems, and then we installed ESXi 6.7 on two of our Supermicro servers. Moving forward, we need to look at ESXi to get a decent understanding of its GUI and what it of course provides. After making sure our networking and storage are properly configured, we move on to the next step. Installing Microsoft Windows Server 2022, configuring it as a domain controller, making sure DNS is functional, and then of course on to vCenter server. But let's start by looking at ESXi. Once ESXi is installed and the networking is set up, we'll see the console screen. This screen will let us know how to connect to this ESXi host over the network. Let's go over to our web browser and type in the address https://10.0.10.20 and 10.0.10.21, as these are both the IP addresses of ESXi 1 and ESXi 2. Like many web appliances, we are presented with a connection isn't private screen. Typically, we would replace the built-in certificate with a trusted cert, but that'll come much later. For now, we just continue to the server. On the Vmware ESXi login, we use the name root and the password were created during the install previously. We do have the ability to send technical information about your usage of ESXi products. I suspect this is a good way to determine if anyone is stealing their software. I always turn these off for all devices because I personally don't like my system sending information out, especially when I don't know exactly what they are sending. So I'll uncheck the box for joining the VMware Customer Experience Improvement Program. When looking at the initial ESXi screen, we are greeted with a lot of information. From here we get various information configuration screens for host, manage, monitor, virtual machines, storage, and networking. On this host screen, we're also giving a link to vCenter server, which we'll install a bit later. We can create or register a VM, shut down the server, reboot the server, refresh the screen, and other various actions that we can accomplish. Some other information is listed here: the FQDN, or fully qualified domain name of the server, the version we are running, the state of the server, and of course the uptime. On the right hand side, we are provided a current state of the physical resources. How much CPU we have free, how much is used, the total capacity of the CPU resources available from this server, how much memory we have free, how much is used, and the total capacity of memory as well. We also have the ability to look at our storage information, how much we have free, how much we have used, and of course the total capacity available. Scrolling down on the host main screen, we see plenty of information about the host itself. On the right hand side, we have some configuration information, which shows us the image profile used to install ESXi, the vSphere HA state, which at this point we have a standalone system. Once we work with vCenter server, we can change this. We also see that our system is vMotion supported. For system information, we see the current date and time of the host, the date and time that ESXi was installed, the asset tag and serial number information of the physical host, which can come in handy when we need to get support from the manufacturer, as well as the BIOS version and its release date. So let's move on to the more interesting information about our server here, the hardware that we have installed. We can see the server's manufacturer. In this case, I'm using a Supermicro model X8DTT. The server has 12 physical CPUs on the Intel Xeon X5675 running at 3.07 GHz. I have 96 gigabytes of RAM, as well as if we have persistent memory and virtual flash, which of course I don't. Networking will show us our host name, the IP address of various VMK or VM kernel ports. for IP version 4 and version 6. We see if there are any DNS servers configured, as well as our default gateway. If IPv6 is enabled, it will show us this information as well. We also see how many host adapters we have installed on this server. Along with the host adapters, we can also see the port groups that are currently configured on the host. Next, we have our storage information showing us how many physical adapters we have, as well as the configured data stores. On the right side, we have a monitoring panel that shows us our consumed host CPU and consumed host memory. Keep in mind, consumed means in use, not configured. You can configure a VM to have 90 gigabytes of RAM, but likely it will only consume a couple of gigabytes. Moving forward, let's look at our storage configuration. Basically, from a simple lab perspective, we want to make sure we have all of our data stores. The data store is where you can save files, ISOs, and where your virtual machine hard disks and other virtual machine configuration will reside. The data store will also list drive type, whether it's hard disk or solid state, HDD or SSD. It will also show the capacity of the data store. Keep in mind, the capacity of the data store can be extended if you're running this data store like on a storage array. We also see how much space has been provisioned, how much space is available, the type of the data store, and if thin provisioning is enabled, and what type of access the data store has. In this case, it's a local disk, so it is a single access type. For networking, we have a lot to worry about here. For example, port groups. A port group is basically a grouping of VM NICs and VM kernel ports. The whole point of a port group is to provide VLAN tagging for the VMs or VM kernel ports attached to that port group. The port groups page tells us which groups have been created, how many ports are connected, the VLAN ID of the port group, the type of port group, the vSwitch this port group is configured on, and of course how many virtual machines are attached to it. If we click on the port group management network, we'll be presented with some information, which we saw previously, as well as some really nice pictographs showing virtual layer 3 ports or the VMK ports. We also have the physical VM NICs applied, and of course the VMs that are attached to that particular port group. On the right-hand side, we'll see the security policy to include allowing promiscuous ports, allowing forged transmits, and allowing MAC changes. We also see the NIC teaming policy. Should changes notify the external switches? The actual policy of NIC teaming, which by default, here we route based on originating port ID. We also have the reverse policy and if fallback is allowed. Lastly, if we have a shaping policy, basically shaping tries to contain the amount of data that can be transmitted. So if you specify 300 megabits per second for shaping, the vSwitch will try to allow only that 300 megabits. As you notice here, we have a layer 3 interface, or VMK0. This has the IP address we used to access this device, 10.0.10.21. It's also configured for VLAN 10, as we configured during the initial setup of this device. Access to this VMK will be teamed based on the originating port ID. Considering we only have a single interface, this switch will only use one of the uplinks unless we add more ports or change the teaming mode. There is quite a bit more information to consider, but I'm going to be doing a dedicated video on ESXi, and we can go over all of these options there. For now, we just want to set up our lab equipment and get vCenter Server installed. I now have two ESXi hosts running 10.0.10.20 and 10.0.10.21. We will be using both of these servers together once vCenter Server is installed. For now, we need to install Windows Server 2022 and create our domain. Opening up our data store and browsing it, I have uploaded the Server 2022 evaluation ISO from Microsoft.com. I've uploaded this ISO to both servers. Next, we need to add a new port group for our server's network. Clicking on Network and then Add Port Group, we have the ability to configure the name of the port group, the VLAN ID of the group, as well as which vSwitch this will be created on. Considering we only have 2 physical adapters, we only have a single vSwitch. We do have the ability to create a new vSwitch without uplinks. This will allow our VMs to communicate internally, but you must keep in mind that these vSwitches will only work between VMs on the same physical host. Without the uplinks, the VMs and VMKs or whatever cannot get off of the host. So we're going to give it the name of servers and a VLAN ID of 10. We also have the ability to modify the security settings here, but we'll leave these as the default inherit from vSwitch, as we do not need to modify any of these options. Until we create a distributed virtual switch, we do have to create the same network or port group on every ESXi host, otherwise vCenter won't be able to vMotion a VM and still provide network access to that VM. So here we're going to create the servers and VLAN 10 port group on the other ESXi host. So now it's time to create our first VM. Let's right-click on virtual machines and select Create/Register VM. Select Creation Type. We can create a new virtual machine, deploy a VM from OVF or OVA, and we can register an existing virtual machine. Typically, OVFs or OVAs are provided by vendors for ease of installation of their particular appliances. Also, if you already have VM data in one of your data stores, you can register it as well. So let's create the new VM here, select a name and guest OS. Here we're going to provide the name for the VM or DC1, as this is our first domain controller. We must also specify the compatibility. Here we will leave the VM hardware at 6.7 as that's the version of ESXi we are running, and we'll specify Windows as well as Microsoft Windows Server 2016 or later that's running on a 64-bit operating system. If we need to, we can enable Windows virtualization-based security. This option makes hardware virtualization, IOMMU, EFI, and Secure Boot available to the guest OS. We'll see a little bit later, by not checking this option, we won't be able to boot using EFI. You can try this out if you like. I typically only allow this if required by the guest OS or security policy. For this lab, I'll just leave it unchecked. Next, we have to select the storage, the data store, or the persistent memory. As we do not have persistent memory, we'll just leave the default as data store 1 as the location for the VM configuration files and virtual disks. Lastly, we can customize the virtual hardware available to the VM. So the virtual hardware, the default here is 2 virtual CPUs, 4 GB of RAM, a 40 gig hard drive. The SCSI controller is LSI Logic SAS. We can also specify the SATA controller, USB controller, and network adapter. First, let's change the hard disk capacity to something a little more manageable, say 120 gigs. Opening up the hard disk's properties, you'll notice we have a maximum size, the data store, and location, but most importantly, the disk provisioning method. By default, it uses thick provisioned, lazily zeroed. Both thick provision options will take up the entire configured capacity on the host disk. VMware will zeroize all 120 gigabytes on our physical hardware if left as default. Eagerly zeroed will zero out all the storage right away, and lazily zeroed will zero out once we access and use the disk. I always specify thin provisioned because the disk will only use the space that is written to. No zeroing of the disks. Keep in mind, if you specify thin provisioning, you may come into a serious issue. You can provision much more than physically available. With this option, you have the potential of filling up your physical disks, and you could lose the ability to write new information if your disks become full. So be cautious and make sure to monitor your disk provisioning versus available space. We also have the ability of specifying shares or the priority of the disk. The higher performance or higher necessary application performance, such as Active Directory or SQL servers, you may want to increase the shares value from normal to something a little bit higher. We can also limit the IOPS for this vDisk if we don't want it to overwhelm our disk utilization. We can specify the controller the disk is on, the disk mode, and if you want sharing of the disk to be available. Keep in mind, vDisk sharing is only possible if the disk is configured for thick provisioned, eagerly zeroed. We need to make sure we have pre-provisioned the network port group and configure it here. As you see, DC1 will be in the server's port group with VLAN 10. For the CD/DVD drive, we can use the physical drive that is in the server if we have one, as well as specify a data store ISO file such as the Server 2022 evaluation ISO we uploaded previously. We need to make sure both the network adapter and the CD/DVD drive are both connected, otherwise they won't work, of course. Lastly, we have the option of specifying the video card. This is really useful when you start running VDI environments. VDI environments basically have video cards made for providing a lot of different VMs to use a single or an array of video cards. Once we're done and ready, we can hit Finish. Now that the VM has been created, we can right-click and see all of the options. Power, Guest OS, Snapshots, Console, Auto Start, Upgrade VM Compatibility, Export, Export with Images, Edit Settings, Permissions, Edit Notes, Rename, Answer Question, Unregister, Delete, Help, and Open a new window. We can go into Settings and modify anything we forgot to set or change configurations. Under VM Options, however, we do have some more options for us. We can specify VM name, the VMware Remote Console options, VMware Tools settings, Power Management, Boot Options, Advanced, Fiber Channel NPIV, and of course VBS. Sometimes we have to change the boot options from EFI to BIOS for the VM to work. As we saw earlier, without the present virtualization hardware to Windows in this case, because we didn't have that allowed to the virtual machine, Server 2022 could not be installed using EFI, hence I'm changing it to BIOS. Let's go back to the VM, open the console, and start the virtual machine. If you want to change the console settings, right-click on the VM and select Console. From here, we can open Browser Console, Open Console in New Window, Open Console in New Tab, Launch Remote Console, and the ability to download the VM Remote Console application. Personally, I like opening up the console in a new tab, so I'll do that. A new tab opens up, and we can see the console of our VM starting Server 2022 installation in this new tab. First, we can specify the language we wish to install, the time and currency, and the keyboard layout. Upon hitting Next, we can install now or open up the Repair Your Computer dialog. Once we hit Install Now, we'll get the Setup as Starting page to start the initial install. In this evaluation, we have the ability to specify Server Core, which is a CLI-based installation, or the Desktop Experience GUI-based installation. There aren't a lot of differences between Standard and Data Center, so at least in the lab, I always choose Data Center Edition so I don't miss out on any potential features that I might need. We can talk about those differences in a dedicated Windows video. We must then accept software licensing terms. We are then offered two options: upgrade if a lower edition of Windows is already installed, or custom install to install a new copy of Windows. Once we select to install the copy of Windows, we need to select the disk to install it on. In this case, we see the VMDK virtual disk we created in ESXi. Pressing Next, we go through the installation of Windows Server 2022. While we wait for Server 2022 to install, let's take a look at some networking configurations. Under Networking TCP/IP stacks, we have vMotion, provisioning, and the default network stack. We need to specify the host name and other network information, so we'll select default. In this TCP/IP stack, we have the configuration which tells us if IPv6 is enabled, the congestion control algorithm, maximum connections of 11,000, the VMKNIC or VMK0, and if DHCP is enabled. On the right side, we have our routing information. This specifies, of course, our default gateway or default route as we configured previously to 10.0.10.1, as well as the local network connection. What we really need to worry about here is the DNS configuration. So we'll edit the stack settings and specify a few things. First of all, of course, we want to change our host name so it's proper, NTR ESXi01, our domain name of ntras.com, and the primary DNS server will be the Server 2022 VM we are creating right now, which will give it an IP address of 10.0.10.10. We are also required to specify a search domain, which in this case we'll just specify as ntras.com. Back at the host screen, we see our host name is changed to ntrexi01.ntras.com. And back on our DC1 console tab, we see that it has finished installing. First, of course, we need to provide a password for administrator. And once we're in, we can click the top button, go to Guest OS, Send Keys, and then select Ctrl-Alt-Delete to be able to log in. Now we can log in as administrator and provide the password we created a moment ago and get to the Windows Server Manager. For now, we're done with a standalone ESXi video. In the next video, we're going to get started installing domain controller services on DC1. After that, we'll get into vCenter Server and finish up our lab on creating multiple ESXi hosts, integrated with vCenter, and creating a cluster. So I hope you enjoyed this video. I hope to see you in the next one, the domain controller services. If you're not worried about the Windows stuff, you can skip this next one and go on to the vCenter server installation and looking at that. Alright, well, I'll catch you later.